The set K has the elements 1, 3, 4 and 6. A is the set of all real numbers whose digits are chosen from K without repetition. Also, the elements of A can have at most 2 digits after the decimal point. Numbers without digits before the decimal point, such as 0.36, are also allowed. Find the sum of all the elements of A. So we'll start by looking at what are all the different forms the elements of A can take. Now they could be 1-digit elements, 2-digit elements, elements which have 3 digits and elements which have 4 digits. 1-digit elements can take the form point A or just A. Similarly, 2-digit elements can take the form point AB or A point B or AB and so on. Now here A, B, C and D are all single digits taken, non-repeating digits taken from the set K. Now what you need to note here is point A is nothing but A times 0.1, right? 0.4 is nothing but 4 times 0.1. Similarly, point AB is AB times 0.01. 0.34 is 34.01 and so on. So the summation of all the elements of the form point A is nothing but the summation of all the elements of the form A times 0.1. Right? So summation of all the elements of the form A point B is nothing but summation of all the elements of the form AB times 0.1. So we'll use that to find the summation of all the single digit, 2-digit, 3-digit and 4-digit numbers. So for the single digit elements we had these two forms, and summation of point A we found was 0.1 times summation of A. So this plus this is nothing but 0.1 plus 1, 1.1 times summation of A. Similarly, for 2-digit elements we had 3 different forms. Summation of point AB is 0.01 times summation of AB, and this is 0.1 times summation of AB, and this is summation of AB. So it is 1 plus 0.1 plus 0.01, which is 1.11 times summation of AB. Similarly, the sum of all the 3-digit elements would be 1.11 times summation of ABC, and 4-digit elements would be this. So this is what we are trying to find, right? This is going to be our final answer. We need to find the summations of A, AB, ABC and ABCD. There are 2 different ways of doing it. We'll look at the longer method first because it is the more general one which is applicable to all kinds of inputs. Summation of A is just 1 plus 3 plus 4 plus 6, which is 14. That's fine. For all these 2-digit elements, let's first find out how many such elements are there. I mean, for how many such numbers are there of the form AB, where A and B are independent digits. Not really independent, they are individual digits. So how many such 2-digit numbers are there? For A, we can choose one of the 4 values in K, right? So once we have chosen one value for A, we would be left with 3 values for B. So the total number of such numbers is 4 times 3, which is 12. Now, in these 12 numbers, consider just the units place digits. These are all 2-digit numbers. Let's consider the units place digits. There are 4 digits which can be in the units place, 1, 3, 4 and 6, right? And there are 12 such numbers. And so each of the digits 1, 3, 4 and 6 should appear 12 by 4 times in the units place, because they should be appearing the same number of times. None of these digits is more special than the other ones, right? So each of these would appear 12 by 4 times in the units place. Similarly, each of these would appear 12 by 4 times in the tens place also. And so the sum of all the units place digits would be 12 by 4 times 1 plus 3 plus 4 plus 6, because it's 12 by 4 times 1 plus 12 by 4 times 3 and so on. This is also the sum of all the tens place digits. So the summation AB is nothing but the sum of all the tens place digits times 10, because these are in the tens place, plus the sum of all the units place digits. So that would give us 10 times this plus 1 times this, and so 11 times 12 by 4 times 14. We can apply the same logic for 3-digit and 4-digit numbers. There are 4 into 3 into 2 3-digit numbers, and so summation of ABC can be written as 111 times 24 by 4 times 14, and summation of ABCD would be this. And you put in all the values in the expression we found earlier, you get the answer. Now, another method that we can use is to find the values of summation A, summation AB, ABC, and ABCD. We can use it in this specific question because the input is given that way. The set K has got 4 digits, 1, 3, 4, and 6. What you can notice there is this set can be split into 2 subsets, the sum of the numbers in each subset being 7. You can club 1 and 6 and 3 and 4. 1 plus 6 is 7, 3 plus 4 is 7. Right? So consider all the single digit numbers first, single digit elements. For each number x, there is going to be a corresponding number 7 minus x, which is different from x. So for 1 there is 7 minus 1, 6. For 6 there is 7 minus 6, 1. For 3 there is 7 minus 3, 4, and so on. For each number there is a corresponding number 7 minus x. The sum of this pair x and 7 minus x is of course 7. Right, so we just need to find the number of such pairs and multiply it by 7, because 7 is the sum of the numbers in each pair. To find summation of A, we just need to find the total number of such pairs and multiply it with 7. And how many pairs are there? There are in all 4 single digit elements, and each pair has 2 elements, so number of pairs is 4 by 2, and the sum of each pair is 7, so summation A is 4 by 2 times 7. Now similarly for 2-digit numbers, for each number x, there is a corresponding number 77 minus x. For example, for 36, you would have 41, right? The sum of x and 77 minus x is of course 77. So to find summation AB, you need to find how many such pairs are there and then multiply it with 77. There are 12 2-digit elements, and each pair has 2 elements, so number of pairs is 12 by 2. Similarly, you can find it for summation ABC and summation ABCD. If you are not able to follow, just think about it for some time. It's quite easy to understand. So you have the values of all the summation A, summation AB, ABC, and ABCD. Put it in the expression that we got earlier and you get the same answer. So basically you need to be looking out for patterns in the input that is given to you, right, in any kind of problem. Often there would be such hidden patterns. If you find those patterns, the problem becomes much easier for you to solve.